Section 3.5 Summary of Curve Sketching. We have about 8 steps, and we need to write those steps down, and we will follow those steps to sketch a curve. Step number 1, we will find the domain. Step number 2, we find the intercepts. We find x-intercept by letting y equal to 0. We find y-intercept by letting x equal to 0. Step number 3, check for symmetry. If we have f of negative x equal to f of x, then we say the function f is even. The function f is even. That means the curve is symmetric with respect to the y-axis. If we have f of negative x equal to negative f of x, then f of x is odd. The curve is symmetric about the origin. If we have f of x plus p equal to f of x, for p is some positive constant, then we say f of x is a periodic function. Step number 4, we will find the asymptote. We have 3 asymptotes: horizontal, vertical, and the slant asymptote. To find the horizontal asymptote, we will find the limit of f of x when x approaches to positive or negative infinity. The answer equal to L, then we have conclusion that y equal to L is the horizontal asymptote. For the vertical asymptote, if we have one of the following statement is true, then we say that x equal to a is a vertical asymptote. For slant asymptote, we must check the degree. For example, we have x to the 5 plus 3x4 minus 10x cubed and so on. And then we have x to the 4 plus 2x cubed and so on. So we check the degree. If the degree on the top, which is in this case is 5, and the degree in the bottom is 4, it's just 1 unit more. Top is 1 unit more than the degree in the bottom, then we will have the slant asymptote. For example, if we have the degree 7 and the degree 6 in the bottom, we will have a slant asymptote also. So it's only 1 unit more, okay? And to get the slant asymptote, we will divide, use synthetic division or long division to divide. This part is the quotient part, ax plus b, then y equal ax plus b will be the slant asymptote. Step number 5, we find the intervals of increasing or decreasing. If f prime greater than 0, then f of x increase, and if f prime less than 0, then f of x decreasing. Step number 6, from the increasing and decreasing, we can find the local maximum or the local minimum. We find the value c so that f prime of c equal to 0 or f prime of c does not exist. We have 2 tests, the first derivative test and the second derivative test. For the first case, when f prime change from positive to negative, we will get the local max. When f prime change from negative to positive, then we will get the local mean. To find the point local max and local mean, we will plug the value c into the function to find the output, the y part. If we use the second derivative test, we will find the value c so that f prime of c equal to 0, and then we find f double prime, then we plug c in the f double prime to see the answer is positive or negative. If f double prime of c positive, we got local mean. If f double prime of c less than 0, we got the local max. The last step to do for Finding more information is step 7. We check for concavity and the inflection points. Concavity up when we have f double ram greater than 0. Concavity down when we have f double ram less than 0. The inflection point is the connection point between concave upward and concave downward. Or it happens when we have the concavity changing the direction from positive to negative or from negative to positive. Then in step number 8, we will sketch the curve. We will combine all of the information we do from step 1 to step 7. The way to do is, first of all, we will wrap the asymptote using dashed line. Then we will plug in the points. We have x-intercepts, maximum, minimum, local minimum, and inflection point. After that, we will connect those points using the increasing decreasing idea in step number 5, concave up, concave down in step number 7. Then we make the curve approach to the asymptotes, and sometimes if we need, we can make more points so that our graph will look nicer.